Welcome back to another day of geometry. Today we get to deal with some sequences to begin with. Today what we're going to do is we are going to write an equation for these two types of sequences, which was briefly discussed in the math notes yesterday, and so I want to re-edify or edify the skills that we developed at the end of the class yesterday. Looking at this first sequence of numbers, remember a sequence is just a list of numbers, and what you're trying to do is to identify some kind of pattern that might be going on. And as I look at these numbers, hopefully you can recognize that to get from one term to the next term, what I'm doing is I am multiplying by 1/2. I'm multiplying by 1/2. I have repeated multiplication as I went through this entire sequence. And so when we had repeated multiplication, we called that type of sequence geometric. So a geometric sequence is a list of numbers in which they repeatedly multiply over and over again. And as such, a geometric sequence is modeled by this general equation. T of n equals a times b to the n, where a is what we refer to as kind of the 0th term, if you will, and b is our multiplier. And so looking at our sequence, I actually know the multiplier, so I could write an equation to model that sequence as something times 1/2 to the n power. Well, this in my sequence, this would be the first term, this is the second term, and this is the third term. So when I write my equation, I need to know the 0th term, which would be going backwards, which would be taking this number and dividing it by 1/2. Or you could think, what number times 1/2 is 1/2? That'd turn out to be 1. And so in my equation, what I would write would be 1. So I have 1 times 1/2 to the n power, and this would be the equation that would model that geometric sequence. Conversely, over here on this problem right here is not a geometric sequence. As hopefully you can recognize that we are not multiplying by the same value over and over again, but instead what we are doing is we are subtracting 2 in each instance to get from one term to the next term. And so we would refer to this type of sequence as arithmetic. And so an arithmetic sequence is again modeled by linear growth. It's repeated addition or subtraction. And the arithmetic sequence looks something like this. T of n equals m times n plus b, where this value right here is what we recall as our common difference, or essentially the thing that you're adding or subtracting over and over again. So that's called the common difference. And this thing, the b value, is our 0th term, just like what we had in a geometric sequence. So as I look at my sequence right here, I know that I'm subtracting 2 every time. So that's going to be the quantity that I plug in for m. And then my 0th term would be taking this thing and going the opposite direction, going backwards to the 0th term. And so I believe that would be negative 5.5 as I would be adding 2 to go backwards to the 0th term. So as I write my equation modeled by that arithmetic sequence, it would be negative 2n plus, or you could just write minus rather, you don't need to say plus, minus 5.5. Beautiful. Geometric and arithmetic sequences, and we'll practice more of this as we move on. So what we're going to do is we're going to learn a new ratio. So we've been talking about this thing called the slope ratio and over again, and that actually has a specific name within right triangles, and that's called the tangent ratio. And so we're going to use that instead of having to lean upon our trig table toolkit with all those special ratios that we've been talking about over and over again. So we're going to go back to the Leaning Tower of Pisa, which is a problem that we dealt with earlier on. It says in problem 4-1, you learn that the Leaning Tower of Pisa is expected to collapse once its angle is less than 83 degrees, and currently the top story is 50 meters above ground and is 5 meters from the base of the tower. So it asks in question A, what is the slope ratio? Remember, slope ratio is just a fancy way for us saying, what is the change in y over change in x when we're looking from this vantage point of this angle right here? Well, the change in y would be this vertical distance, and the change in x is the horizontal distance. So the change in y over change in x in this case is 50 over 5, or 10, if you will. And so it says, use your trig table toolkit to determine the angle at which the Leaning Tower of Pisa slants. So going to my trig table toolkit, if I see something that a ratio of 10, I don't expect you to have this out in front, that corresponds with an 84-degree angle. And so an 84-degree angle is what this angle is measuring right now within the Leaning Tower of Pisa. So it says, is it in immediate danger of collapse? Well, I guess that's in the eye of the beholder. 84 degrees is really close to 83 degrees. So I would say they should probably figure something out to keep that thing from toppling over. So on this problem, it says solve for the variables on problem 34 and the triangles below. It might be helpful to orient the triangle excuse me, by rotating the paper using tracing paper so that the triangle resembles a slope triangle. Use your trig table for a reference. So you can go back to another video where I asked you to take a screenshot where they keep saying trig table. But those are just the ratios of the sides of certain slope angles that we have. What they mean by orienting your triangle. If this is the angle that we are looking at, we want to determine the change in y over the change in x. Remember that this would be the vertical distance, or the distance across from that side, and this would be the horizontal distance right here. So that triangle could be oriented more as this. Something, here's theta, here's 12, here's w, here's 79 degrees. And so it asks you to solve for the variables in the triangle. So we have two variables in this problem in letter A that we want to solve for. Well, I can solve for theta pretty easily. I know that this is a right triangle and this is 79 degrees up here. That means that theta has to be 11 degrees. And I also know 11 degrees is the first ratio that we knew, or we discovered. An 11-degree angle meant that it had a slope ratio of 1/5. So therefore I know that 1/5, that ratio has to be equal to w over 12. And so we can cross multiply within our own triangle here, and we get 5w equals 12, and then you divide both sides by 5, and you get w equals 12 over 5. And so we can use those similarity of triangles with the 11-degree slope angle to try and determine that missing side length. I'll pause the video for a moment, and I'll let you go through and try and determine the measurements of the other two in parts B and C. Looking at these last two triangles, hopefully you're able to determine that theta in part B would be 68 degrees. And so I could set up a ratio of 68 degrees. I know has a ratio of 5 over 2. That was from our trig table. You could reference that. So I set 5 over 2 equal to 8 over z and solve, and I got 16 over 5. In letter C, I reoriented my triangle to make it look more like something I'm familiar with. So here's my x value, or my horizontal distance. Here's my y value. I found that theta was 72 degrees. The ratio for a 72-degree angle is 3 over 1. So I took 3 over 1 and I set that equal to 15 over x. And when I did that, I found x equaled 5. Alright, so we're going to move ahead to problem number 36. And problem number 36 says, according to the triangle at the right, what is the slope ratio for 32 degrees? So here's 32 degrees, and if it's helpful, we can reorient the triangle so that the 32 degree is in some manner or orientation that's a little bit more accessible for us, where we can recognize where the vertical and the horizontal component lie. And so what I mean by that is, here's 32 degrees. This would be my change in y right here, and this value down here is my change in x. So the value for the slope ratio of 32 degrees would turn out to be 5 over 8 in that instance. And so it says, what is the ratio? Read it in both fraction and decimal form. Well, 5 over 8 is the exact same thing as 0.625. That's going to come into play here in just one moment. It says, what is the slope ratio for the 58-degree angle? Well, I don't need to do any work. I know that 58 and 32 degrees are complements of one another. So this angle up here and this angle are complementary. And remember, if you have complements, we can just take the reciprocal of that, which is going to be 8 over 5, or 1.2. Excuse me, that's not 1.2 at all. That would definitely be 1.6. And so 8 over 5 would be the slope ratio for the 58-degree angle within that triangle. It says now in part C, scientific calculators have a button that will give you the slope ratio when the slope angle is entered. So now they're really saying, hey, we don't have to go back to this trig table anymore. We can use a button called the tan button on your calculator to verify that you get 0.625 when you enter 32 degrees. And so what we're going to show you here in a moment is how to do that in your calculator. And what I would encourage you to do is I would either go to Google or take out your calculator, Google, you just type it in, scientific calculator. What you're going to enter is you're going to type in tangent of 32 degrees. So it looks like TAN, tan. And one thing that we need to make sure that your calculator is in is this thing called degree mode. And you want to make sure that it is in degree mode and not radian mode. So verify that your calculator is in degree mode. And so how you can do that right now is if you enter tangent of 32, so you're looking for the button that says tan, and then you're going to enter in 32, and then you're going to hit enter within your calculator, either online or the one that's personal to you, and you should end up getting that the tangent of 32 is approximately 0.625. If you're not getting that, then what needs to take place is I would go to YouTube and I would figure out, hey, how do I change my calculator from radian mode to degree mode? It's a very simple switch. You press mode, you scroll down, you highlight degree and hit enter. But that's the value that you should get. Okay, so the big idea here on letter D says the ratio in a right triangle that you've been studying is called the tangent ratio. When you want to find the slope ratio for an angle such as 32 degrees, like this, we don't need to go to our trig table anymore. We have a calculator that will calculate that slope ratio for us. And this ratio is called the tangent ratio. And we're going to go to the math notes on the next slide to really edify this idea. So I kind of skipped ahead 2 slides, and we'll go back and practice here in a little bit. But it says for any slope angle in a slope triangle, the ratio that compares the change in y to the change in x is called the tangent ratio. So this deal right here and this picture right here are things that should be written down somewhere safe and secure. And so one way to identify which side is the change in y and which side is the change in x is to reorient the triangle so that it looks like a slope triangle, like this. That's why we practice reorienting our triangles. And so what we are trying to get across is that the tangent of any right triangle is truly the opposite leg over the adjacent leg. And what we mean by that is, if this is my angle of reference that I'm referring to, the side length that is across from the right angle, remember, in a right triangle, this side length right here is always called the hypotenuse. So that gives us 2 other legs that we want to try and determine. And so the side length that is across, that is not the hypotenuse, the side length that's across from your angle that you're looking at, this is referred to as the opposite leg. And the side length that is immediately next to your angle of reference that is not the hypotenuse, this is referred to as the adjacent leg. And the tangent ratio is looking at the ratio of the opposite leg to the adjacent leg, or it's P over R as they have in this instance right here. But tangent is really the more formal idea of what we've been talking about with slope ratios within right triangles. And so that is equal to the change in y over the change in x, or is what we're going to call the tangent over, or the tangent of an angle is equal to the opposite over the adjacent leg. And we'll practice that here in just one moment. So going back to problem 37 now, it says for each triangle below, trace the triangle on tracing paper. You don't need to do that. What I would do is I would draw these triangles, and what we're going to do is we're going to use our scientific calculator to help us determine the missing values. And so here's what I would encourage you to do. First of all, always write the triangles or draw them. Identify the angle that we are looking from. So here's a 38-degree angle in part A. The side length across from the right angle is always called the hypotenuse. Okay, so our problem or our issues now involve using the other 2 side lengths. which should be this tall one and this short one, so the ones that are not across from the right angle. The one that is across from the 38 degrees is always referred to as the opposite side. The one that is next to the 38 degree angle is called the adjacent side. And so what we just wrote down in the math notes previously is that we can say the tangent of some angle is a special name of talking about the slope ratio of an angle is equal to the opposite leg over the adjacent leg. And so what that means is that I can set up an equation. I can say that the tangent of, I know that theta is 38 degrees. Remember, theta is just a name for a variable. That is equal to the opposite leg. Well, the opposite leg I don't know. That's just x. So I'm going to write x divided by the adjacent leg. And the adjacent leg is 8. So what I do now is I want to set this up as a ratio to solve. And in doing so, what happens is I'm going to put this fraction on the left over 1 to make it a fraction. And I'm going to multiply both sides across as such. So I'm going to get that, when I multiply across, I'm going to get that 8 times the tangent of 38 degrees, that's just a number, is equal to x times 1, which is just x. And so now when I just type that into my calculator, I'm going to find that x is approximately 8 times the tangent of 38, which is approximately 6.25. And so I use the tangent ratio then in order to help me solve for that side length that's missing, which is 8. And so what I'm going to do is I'm going to ask that you try letter B and letter C, see if we continue. Really just more letter B. I'll talk about letter C right now. That one should be hopefully rather straightforward. If we know that this is a 45 degree angle, that means that this one's got to be 45 as well. And this is an isosceles triangle. Remember that slope ratio is 1. So if this is 14, that means that x right here also has to be 14. And so if you wanted to, you could set up a ratio of tangent of 45 degrees equals 14 over x, and you could solve, but you'd get x equals 14 either way. Why don't you just pause the video for a moment and try letter B on your own. See if you can identify the opposite and the adjacent leg, and then we will move forward. So I'm going to pick it back up right here. Hopefully you're able to identify that 9 is the opposite side length of 75 or 73 degrees, and x is the adjacent leg. So as I set up my ratio, here's what I did. I said the tangent of 73 is the opposite over the adjacent. That's the ratio that we use for tangent. And in doing so, then I cross-multiplied to try and solve for my variable x. Now in the process of doing that, what I'm left with is 9 equals x times the tangent of 73 degrees. That one's a little bit different from the previous problem, and so what I want to do to get x all by itself is I'm going to divide both sides by the tangent of 73 degrees. The tangent of 73 degrees, remember, is just a number. And so I'm going to do that, and these are going to cancel each other out. And then what I'm left with is x equals, sorry, one moment, my iPad wasn't cooperating. X equals 9 divided by the tangent of 73 degrees. So what you do in your calculators, you type in 9 divided by the tangent of 73 degrees. And when you do so, you end up getting approximately 2.75. So we can use this thing called the tangent ratio. And tangent, again, is equal to the tangent of an angle is equal to the opposite leg over the adjacent leg, and we use that to help us solve for missing side lengths within right triangles. Lastly, what we're going to do is we're just going to apply this into a real-world setting, which is one problem, problem number 45, talking about the Statue of Liberty. And so the Statue of Liberty, obviously a very famed place, it says is more than 300 feet above the ground. And so Lindy gets nosebleeds whenever she is more than 300 feet above the ground. So during a class field trip, her teacher asked if she wanted to climb to the top of the Statue of Liberty. And so since she doesn't want to get a nosebleed, she decided to take some measurements to figure out the height of the torch of the statue. And she found a spot directly under the torch and measured 42 feet away and determined that the angle up to the torch was 82 degrees and her eyes are 5 feet above the ground. So will she get a nosebleed? And so what we're trying to determine is will she get a nosebleed? So we need to draw a diagram for this. So in order to draw a diagram, I'm going to put the torch of the Statue of Liberty roughly right here, and I'm going to draw a triangle to represent my situation. So in order to do that, I'm going to create a triangle, and here's Lindy. She's standing somewhere like this, okay? And some of the information that we know is that this is an 82-degree angle. I know that that measurement is 82 degrees. She found a spot directly under the torch and then measured 42 feet away. And so this distance right here is 42 feet, and we don't know this distance, which I'm going to call x. I also have to remember that her eyes are 5 feet above the ground. But using this right triangle here, what we're going to do is we're going to use the tangent ratio in order to determine the height x. And we know that the tangent of any angle is equal to the opposite leg over the adjacent leg. So filling in what I know from this triangle, the angle of reference that I have is 82 degrees. So the side length across from that is the opposite leg, and the side length immediately next to it is the adjacent leg. So when I fill in some of my equation over here, I can say the tangent of 82 degrees equals the opposite leg x over the adjacent leg 42. And as a reminder, we can put this over 1, and then what we're going to do is we're going to cross multiply to try and determine the value of x. And in doing so, I'm going to get that x equals 42 times the tangent of 82 degrees. That sounds pretty cool, and when you type that into your calculator, you're going to get that this is approximately 299 feet. Okay? So one thing that we need to make sure of then is that, hey, well, that's 299 feet, but we need to remember that her eyes are 5 feet above the ground, so we need to add 5 to that, which would be 304 feet. So should she climb up? The answer would be no, don't climb up, because the torch is 304 feet above the ground, which would give you a nosebleed. So today, as a reminder, we talked about this tangent ratio. We're going to be practicing that a lot more moving forward. Please stop by for office hours if you need some additional help and or resources. I'd love to do that for you. Stay safe and stay healthy.